Hello everyone, I am Dr. Anupama Chowdhry Devgan, your physiology faculty. In the run-up to the INICET November 2025 exam, I am starting a series wherein I will be discussing the important images and graphs in physiology. So today I'm starting with renal, and this is part 1. So let's see which is the first graph here. Now this has already been asked as an INICET question. The relative filtrability of the three types of dextrans of different molecular radii is depicted below. Graph A represents which of the following? Now, here there are three dextrans. One which is neutral with no charge. The other is polyanionic, that means has a negative charge on the surface. And the third is polyketinic with a positive charge on the surface. Now we know that the glomerular filtration membrane has got a negative charge. So this will repel negatively charged substances and attract the positively charged substances. Now, on this graph, let's look at the x-axis. The x-axis has the effective molecular radius and the relative filtrability given on the y-axis. One would indicate that it is freely filtered. Now, if you look at this, let's take effective molecular radius of 30 angstroms or 3 nanometers. Now, substance A has the least filtrability. Then we have the neutral dextran, which has a slightly higher filtrability, same radius as substance A, but substance A has some charge on the surface and the neutral dextran does not have any charge. So the neutral dextran has a higher filtrability than substance A of the same molecular radii. Substance B has the greatest relative filtrability, even more than the neutral dextran of the same molecular radii. So that means A, which has the least filtrability, is being repelled. B, which has relatively highest filtrability, is being attracted. So in other words, B is polyketinic and A is polyanionic. Same molecular radii, the anionic substance will have the least filtrability, the cationic substance will have the greatest filtrability. This is because the negative charge on the glomerular filtration membrane will repel the negatively charged dextran, so least filtrability, attract the positively charged dextran, so greatest filtrability. So A here is polyanionic dextran. Let's look at this graph. Very, very interesting. We've got the atrial pressure on the x-axis and ml per minute on the y-axis. Now this tells you that the renal plasma flow and glomerular filtration, these are constant in a particular pressure range. Now what is that pressure range? Between a mean arterial pressure of 90 and 200 millimeters of mercury, the renal plasma flow and therefore the GFR, these are constant. Extremely important to understand. That means during the day there are variations in blood pressure, but this is not going to affect either the renal plasma flow or the GFR. As you can see over here, the GFR is approximately at 125 ml per minute and the renal plasma flow is between 625 and 650 ml per minute. And between a mean arterial pressure of 90 and 200 or sometimes even 210 millimeters of mercury, it is going to be constant. Now, as far as GFR is concerned, there are 3 autoregulatory mechanisms for maintaining the GFR constant. Again, this has been asked as an INICET question. Which are the three autoregulatory mechanisms? There is a myogenic mechanism for autoregulation of GFR. There is TGF, tubulo-glomerular feedback, and the third one is the glomerular-tubular balance. These are all autoregulatory mechanisms in the kidney which maintain the GFR at 125 ml per minute between mean arterial pressures of 90 and 200 millimeters of mercury. Let's look at this graph. We've got plasma concentration on the x-axis and clearance in ml per minute on the y-axis. We have to identify which is substance A, B, C, or D. Now, C has a clearance of 125 ml per minute, and we know that the clearance of inulin is equal to GFR, which is 125 ml per minute. Now, why is the clearance of inulin equal to GFR? This is because inulin is a substance which is freely filtered, not reabsorbed, not secreted. So the rate at which it is cleared from the plasma is the rate at which it is being filtered. So we say clearance of inulin is equal to GFR. Now, any substance which is reabsorbed. What is reabsorption? Reabsorption would mean that it goes from the tubular fluid back into the peritubular capillaries. That is reabsorption. So if a substance is reabsorbed, that means the volume of plasma free of that substance in unit time. That is the definition of clearance. What is clearance? Volume of plasma free of that substance in unit time. So if a substance is reabsorbed, volume of plasma cleared of that substance or free of that substance in unit time will start reducing. So all substances which are reabsorbed will have a clearance which is less than the clearance of inulin. On the other hand, if a substance is secreted, that means it now enters the tubule from the plasma. So volume of plasma free of that substance in unit time will now increase. So all secreted substances will have a clearance which is more than the clearance of inulin. So now let's look at substance D. Now here is a substance whose clearance below a certain plasma concentration is 0. We know that glucose below renal threshold. What is renal threshold? Renal threshold is the plasma concentration beyond which glucose begins to appear in the urine. So when the plasma concentration of glucose is below renal threshold, whatever glucose is filtered is going to be reabsorbed. That means there is no urinary glucose. What is the formula for clearance? Clearance is UV by P. If urinary concentration is 0, clearance will also be 0. So below renal threshold, the clearance is 0. This is glucose. But beyond renal threshold, that means when the plasma concentration of glucose is more than renal threshold, it begins to appear in the urine. So its clearance, UV by P, urinary concentration is now increasing, clearance will start increasing, but will always be less than the clearance of inulin because at least some glucose is being reabsorbed. So D is the clearance of glucose. Let's look at substance A. Very high clearance in low plasma concentration. But as the plasma concentration increases, clearance decreases. This is the clearance of para-aminohippuric acid. What is para-aminohippuric acid? This is a substance which is freely filtered and completely secreted in low concentration. And the clearance of para-aminohippuric acid in low concentration is equal to renal plasma flow, which is 625 ml per minute. Clearance of para-aminohippuric acid in low concentration is used for the assessment of renal plasma flow. Why? Because para-aminohippuric acid in low concentration is freely filtered and completely secreted. But as the plasma concentration of para-aminohippuric acid increases, the secretion starts reducing. Why? Because para-aminohippuric acid is secreted with the help of a carrier protein. So carrier proteins tend to get saturated. So as the plasma concentration of para-aminohippuric acid increases, the secretion decreases. That means clearance decreases, but will always be more than the clearance of inulin because at least some secretion is taking place. So A is the clearance of para-aminohippuric acid. Let's take B. Clearance almost equal to the clearance of inulin, slightly more. This is the clearance of creatinine. Why creatinine? Creatinine is freely filtered and slightly secreted. So its clearance is slightly more than the clearance of inulin. So A here is para-aminohippuric acid. Low concentration, very high secretion. As the concentration increases, secretion reduces. So low concentration, very high clearance. In high concentration, the clearance reduces. B, creatinine, freely filtered and slightly secreted. C, clearance of inulin equal to GFR, equal to 125 ml per minute. D is glucose below renal threshold, zero clearance. Above renal threshold, clearance increases but is less than the clearance of inulin. Let's look at another graph. Now again, we have to identify substances A, B, C, and D. Now we've got Bowman space, proximal tubule, distal tubule, urine on the x-axis. And what we have on the y-axis is percentage of the filtered load remaining. Now if you look at substance C, in the Bowman space, the percentage of filtered load is 100. As it passes through the nephron, PCT, DCT, urine, the percentage of filtered load is unchanged. Yes? So that means this is a substance which is freely filtered, not reabsorbed, not secreted. The percentage filtered load is remaining unchanged. So this is inulin. Let's look at substance A. Bowman's capsule, filtered load 100%. It's a freely filtered substance. But even before it crosses the PCT, its filtered load is 0. That means it has been completely reabsorbed in the PCT. What is A? Glucose, below renal threshold, of course. Amino acids. These are freely filtered and 100% reabsorbed in the PCT itself. Let's look at substance B. 100% in the Bowman space, that means freely filtered. And as it passes through the PCT, most of it has got reabsorbed. There is some more reabsorption which takes place in the distal tubule, thick ascending limb distal tubule, and hardly anything in the urine. This is probably bicarbonate. Bicarbonate is freely filtered and completely reabsorbed. 80% in the PCT, the remaining 20% in the thick ascending limb and DCT. So this is probably bicarbonate. Let's look at substance D. 100% in the Bowman's capsule, freely filtered. But as it crosses the PCT, the percentage of filtered load has increased. In other words, in the PCT, it has been added to the tubular fluid. That means it has been secreted in the PCT. And which is the substance which is secreted in the PCT? This is para-aminohippuric acid. So please look at this graph. How are we going to tackle this? Look at the y-axis. It says percentage of filtered load remaining. So he's taken 4 substances, all 4 of which are freely filtered. So they're starting at 100% in the Bowman's capsule. Substance A, Before the end of PCT, 0 is remaining. That means it is completely reabsorbed. Glucose, amino acids. Substance B, at the end of PCT, almost 80% has been reabsorbed. Remaining is less than 10-15%. So this is bicarbonate, which is further reabsorbed in the thick ascending limb and the distal tubule. C, percentage of the filtered load remaining is unchanged. So it's neither reabsorbed nor secreted. Substance D, percentage of filtered load 100% in Bowman's capsule increases in the PCT. That means it is secreted. So this is para-aminohippuric acid. So these were a few graphs from renal physiology. Hope you enjoyed the session.